Okay, so how to access files? We said we're going to use dataset that comes with the software, and with the dataset now, I want to focus more with inferential analysis, because there's nothing much you can do with STATA as long as you're comfortable, you understand what you want to achieve. With STATA, you just go straight and write your commands. So I'll not be using do file or log file, but at least again by now you have an idea on how those two works. So today let's just focus more on now analysis and making sure that we can make sense out of our data. So to access some file, just go to example dataset, file, example dataset. And I also believe you're doing the same on your end, so that just in case you face some error, this is the time now we can have that conversation. Okay, so if you find that I'm moving fast, feel free to let me know. So if you go to file, example dataset, we'll have access to dataset that comes with the software. If you go to now example dataset installed with STATA, that is where now we can access now those files. And it's the same way we had the chance during SPSS. So if you can truly interact with both dataset from both softwares, you'll really be somewhere, because these classes is not about how many books you will read or how many tutorials you watch. If you cannot do it practically, these things you'll forget them in a few. So if you click on example dataset, you will see now all these data files. And as much as I'll use one in class today, I think I'll use two today. Find time and interact with as many as possible. So I'll be using and I think what we discussed also yesterday on what do you call it? How the extension for STATA. So how do you know a STATA file? We said it has an extension of .dta. So if you look at all these files here, all of them has, like for instance, the first one is auto.dta. So that's how you tell the file format. So if I click on describe, of course you remember the command describe. We said it provides details on your data sets. So let's use that before we actually open the data set. So if I click on describe and then I minimize this window, you realize it says what? This data set is contains 1978 automobile data, and it has 74 observation, 12 variables, and that's their size. In terms of the variables that are there, we have the make of a car, we have the price of that car, and you have a variable MPG. So how do you know what MPG is? This is where we talked about labels for your data. So if you don't know the variable name, now go and see how that data was labeled. For instance, the make of a car, of course, automobile means cars. I hope we're the same page here. So the make of a car is a string variable, and you can tell here it's a str18. That means it was coded as a string variable with 18 characters tops. So of course, bear in mind on how we code data into STATA or variables. And we said if you're dealing with a variable that the observations are in number, STATA already understand that. But when you're dealing with observation that if you're dealing with variable that are observations are numbers, the software already knows that. But if you're coding an observation that are strings, you have no choice but to specify that the variable you are creating is a string. That's why we have the str here. Why am I emphasizing on this? I'm preparing your mind towards now what you'll be diving in future, and maybe for now sequel in business intelligence, you realize you will need to maybe create database, and it's the same thing. So what we have been creating all along are what we call database. There's nothing new. So as long as you understand these rules, you will have a very smooth ride in all of these classes. So now that I've checked or I have understood this data, because the first thing is I don't want to be just opening any data. So describe enables you now to see the elements of the content of your data. So I can minimize that. Sorry. So I can now, instead of describe, you can use. So if I click on use, and I can close this interface since I don't have to use it, you can tell that at the variable view, now I have observation. And to check the element, you said you can use the command browse. And if you write browse in full, you will get an answer, but you don't have to be writing commands in full. So if you just write BR, the software already understand what you're doing. So if you look at this data set, the make of a car, we have Concord, we have Pesa, so all these are AMC, and then we have Chevrolet, we have Dodge, we have Mercedes, and so forth. So let's start by now understanding the analysis part. And we said when you're doing data analysis, first there are two analyses that you will do. You do two analyses, both of them. So you start by descriptive analysis and then inferential analysis. And before we dive into maybe this inferential analysis, let's play around with this data set. And we said first, by just observing your database, you can tell the type of variables you are dealing with, because variable types are what will enable you to know what type of analysis you're going to do. For instance, if you're analyzing what do you call it? If you're analyzing a continuous variable, then you know that the type of analysis you're going to do is measures of central tendency. If you're analyzing a categorical variable, then you will know the type of analysis that you're going to do. You will extract a frequency table. So we close this one, and before I close it, you can tell that if you see a variable that is blue in color, say these are categorical. So to analyze foreign, you will have to perform or extract a frequency table. If you want to know the gear ratio, there's displacement, there's length of that car, there's weight of the car, there's trunk, there's headroom, there's price of the car. All these are black in color. And it said if you see a variable that is black in color, then that is a continuous variable. Red in color, we say that is a string. Even if there are numbers, but if it's in red, you will know that that is a string. So hopefully today we'll also have a chance on how to, or maybe just let me demonstrate. So in an event that you have red in color and you say that is a string, we know very well in SPSS we did what we called recoding, whereby we had to convert a variable that was initially coded as a string now to numeric. So just a quick one, if you want to convert a string to numeric, just come here to data while you have edit your work, and if you go to create or change data and then other transformational commands, you will see an option of convert variable from string to numeric. Hopefully we'll have a chance to do it practical, but for now let's proceed with some descriptive analysis. But you said if you're in a position whereby you're seeing your observation are red in color, even if you're seeing them as numbers, that means that variable is string, and you cannot do this kind of analysis with variable that are string. And the first step you'll have is to convert now a string to become a numeric. And I said we'll try and see a data set with such an example. So let's run some field descriptive analysis. So if I want to know if a car is either foreign or domestic, we said for categorical variables, you can either use the command tab. Let's see what tab will do. And we check on the car type. And we can tell that most of the cars here are domestic. That means they're manufactured in the US. And then only 22 of them are foreign. That means they're not from the US. Apart from tab, you can also use table. So let's just play around with this one. And tab and table, they play more or less the same. So where am I coming from? So like I said, even if you just write BR, it means the software already understand what you mean by that. Okay, so instead of writing table in full, you can write tab. But also, if you write table in full and you check now maybe on the make of a car, let's see what you're going to get there. I'm getting a funny result, but let's just stick with the categorical, because now I'm violating the rule which says what? When you're handling a categorical variable, that is when you extract frequency. So this one I'm getting all the observation as unique because my data is not categorical. So let's see what table will provide for us. So if I write that table, then still the same variable is foreign. Now you can tell that I'm getting now a result that is making sense, which is the car type and also the frequency. So the difference between when you use tab and table, you can tell that by use of tab, you have both the frequency and also the percentage and cumulative percentage. But when you're using table, you only have the frequency. So it's up to you to decide on what you want to achieve. So if it's just maybe an analysis that you are doing as you keep on doing other stuff, again, not all analysis is just meant to be saved and transferred to your client. Sometimes you just have to understand your data set by playing around with it as it can make sense. So let's not have that mindset of everything you analyze should be to be transferred or to be taken to somebody else. You can also be just doing it for your own analysis. So we have just said, or we have identified that most of the cars in this dataset are domestic, and then followed by frequency. Let's learn also about tabulate. It's just still playing around with frequencies. And tabulate mostly is used for cross tabulation. So let's have tabulate, and then I still pick foreign because it's the only categorical variable in the dataset. So for tabulate, you can tell that it provides for you results that is more or less the same as tab. So we are learning that tab and tabulate perform the same role. And what is this role? When you use both of them, you'll be able to get the frequency and also the percentage. But for tabulate, if you have two variables, assuming we had I think I'll have just a quick one so that to proceed. Let me get a different data set that has most of these things I'm talking about, and then we'll still come back to the same automobile data set. So I'll be playing around with two of them. So if I just go again to file, and the reason why I'm logging out is because I cannot have two data sets in my variable view. That's why I have to exit and remove everything that is already there so that I start afresh. So let me go to example dataset and then use example dataset installed with STATA. But this time I want to use the National Longitudinal Survey for Women. Okay, NLSW88. That's the one we can use for that we get clear on these things. So if I use and then close that interface, I have a new dataset in my variable view. And if I browse, now you can tell that this one has a lot of blue. And the rule was blue, that is categorical, black, that is continuous, and then red, it means the variables are string. So let's play around with this categorical. And the same, so let me just focus with, sorry about that, for cross tabulation. And I might want to know, maybe I want to get some insight on distribution of married across the different races that are there. And if I tabulate, then I select someone's race and also their marital status. If I execute that, you can tell that now I have a cross tabulation. So I can tell that we have 497 whites who are single, and then 309 are blacks. So you can say most of the race are actually white. That means there are a lot of whites who are single compared to blacks. But if you go and check on marital, on those who are married, then again more whites are married compared to blacks. But now the margin is bigger as compared to single. So I'm sure right now you can tell when to use table, tab, and let's confirm about tab. So I can just say tab. But this time let's look at college graduate and marital status. And as you can see, we're getting again more or less the same results. So these two are same results, different commands. And you can tell here that we have majority of individuals who are single actually are not graduate compared to college graduate. And then we also have those who are married and are not college graduate are actually 1,000, which are more compared to those who are graduates. So this is just getting a cross tabulation, but it depending with what now you want to explain. But as you can tell that tabulate and table, they tend to perform more or less the same thing. And you'll also see when we'll be working with chi-square test. Now, for continuous variable, we said we will use, or the test that you will do is measures of central tendency. That is if your variables are continuous. So I can try and do a descriptive on age, is a continuous variable. And then I also have wage. I have a lot of continuous variable here. The command is summarized with a Z. We talked about this. Or you can just write SUM. And if I select now age of an individual or their wage, I should be good to go. Now I can say on average, the age of my respondent stands at around 39. And on average, they tend to earn a wage of around 7.7 per hour. You can introduce conditions. And we said condition comes with the use of a function if. So you might analyze for grade, but you want grade for maybe only blacks. Here's an example. You want to analyze the grade. But these grades, you don't want to analyze for everyone. So you're bringing in again the issue of conditional, the one we said either in spaces we are using select or split. So in this case, I will say summarize. And what are we summarizing? You select the continuous variable. Let's say summarize grade if someone's race. So how are the race coded? So for you to know how these different races are coded, I think it's good you do some code book. You said if you write code book and just press enter, you'll get now for all the variables that are there. And of course, I don't want to be keeping on clicking on this part of more. So I'll have to set that off. So I'll say yes, set more off. And then let's now confirm for. So again, with if you do code book without specifying the variable, then it means you get a description of your variable for the entire database. That means all the variables that are there. But now I want to know the different values that have been assigned to race. So if I do code book and then I select the variable race, now I can tell that, of course, I'm also getting some frequency, but I'm not in the business of doing analysis. I just want to know what values are blacks attained, so that when I do my descriptive analysis, I will know how to get blacks. Of course, this way I'm now allowed to equate race with that value. So to get summary report for grade, I'll say summarize grade if race, and say now here is where you will use double equal sign. And double equal sign here, it means you're equating what is on the left side to what is on the right side. These are concepts that you should pay attention, because you will also require the same knowledge in other classes, whereby we said what if you use an equal sign, it means that is an assignment function. But when you're using double equal sign, then that is a okay. So summarize grade if race is double equal sign, now the value of 2. So if it was a string, then you enclosed in a speech marks. If I run that, now I can say first only 582 respondents are blacks. That's the condition, and their average grade stands at 12. Now I think that's most of the things. I might not go ahead and maybe talk about list. We said list is just provision for how each respondent was providing their answers. But allow me now to dive in and run correlation regression, and then we also talk a bit on t-test. So once you've done your descriptive analysis, the next thing we said is now inferential. And with inferential analysis, you will follow 5 steps. And right now, I'm sure we are all on the same page on what these steps are. First, talk about that test statistics. What test statistics are you doing? And what makes you determine the test statistic? We said is you look at the structure of your variable. So if you're checking relationship between two categorical, we said chi-square test of association is what you do. But if you're checking relationship between continuous, then Pearson correlation is the test statistics. If you're checking the relationship between a continuous variable and a categorical, and this categorical must have two groupings. Now let me just touch on independent sample t-tests and all the t-tests that are there. So we have around 4 of them. And the first t-test, we call them so we have independent sample t-test, and the independent sample t-test is when one of the variables is continuous and another one is categorical, but the categorical one has 2 factors. That means 2 groupings. We have one-way ANOVA, and one-way ANOVA is when now one of the variables is continuous and another one is categorical, but the categorical one has more than 2 groupings. The other test that is there on comparing means is now paired t-test. And for paired t-test, this is when you're comparing a continuous variable and a categorical variables, but both of these observations are provided by one person or one respondent. So you can have something like a child's education and also mother's education and father's education. So you realize all these data sets are provided by one person. Or you want to know, is there a significant difference in the education level of a child based on the parent's education level? And now with the parent, you have both parents, so you have mother and father. But most of these things are now what we discuss in advanced class. So right now, I should not worry you a lot with most of these test statistics, but I would say at this level, make sure you at least understand the whole process behind inferential analysis. It's not always about just knowing these different types of analysis, but there's now a class for that. I hope we're on the same page. So if you're coming in as a social scientist, you realize most of these things that I might be talking about, you might not have the background, but at least by now, at least understanding how the environment for inferential analysis operate, you can now dive deeper and say, oh, now I know chi-square. Can I go and say if there's a test that is involved in comparing means? Now, how many means are there? I think there's one more test for comparing means, and you'll go and find out. And this is where now you're comparing means for a specific. So you have been given a mean, let's say 50. So you want to know if actually the price of unga in Kenya, I'm not so sure what it is. Is it 200? How much? Okay, assuming the price is 200 for unga. So somebody comes, or the president comes and tell you today, I want to know if the average price is still 200 or it has dropped. So if you're the one who has been given that job to tell if the prices have dropped on average, the entire country is at 50, then it means you will collect data for all the all the different prices that are charging or are charged by maybe shops, and then now you formulate an hypothesis which now questions if the average price of unga is actually that 200. So that's another way of comparing means. So go and find out what is that test you do when you're comparing means with a specific mean that you've been given. And I think the answer that you'll be looking for, it's provided in this do file. That's why I told you yesterday, find time to go through this do file. And if you look here, there's now the part of t-test. I think we'll talk about that a bit later. When so let's continue with the data set that we are having. And we said the steps we are following for inferential is identifying the test statistics. So I've already listed a few for you. the second step is now we say, hey, are you in a position to formulate a hypothesis? And in most instances, you realize now as a social scientist, you will be the one to formulate your own hypothesis. And I talked about this. You are now, so we have two hypotheses. And what is an hypothesis? We say this is an assumption or a claim that you have, but now you have to go through some sort of investigation. And that's why it's called a research process. If you don't have any evidence, or if you don't have a methodology that now you can come and say, hey, this is my problem statement, and I decided to formulate either an hypothesis or an objective. And when you said an hypothesis, you say that now I have an assumption. And based on this assumption, there are two ways to go about it. Either you stick by the status quo. And when I say stick by the status quo, now this is where you have to formulate a negative statement based on your objective. And for instance, I think we use, in this case, we can say what? You want to know if there's a difference. Okay, so you look at this data set and say, oh, I'm seeing we have different race, and we also have different marital status, and we also have different graduate levels. So can you formulate an issue here? Say, okay, I want to know if there's a difference in graduation among the different races that are here. And because you don't have evidence to say that there is a difference, then you stick by the status quo by saying what? There is no difference in graduating level among the different races. But now whatever findings that you think is triggering you now to perform this study, that now becomes your alternative hypothesis. And you say, oh, maybe with my descriptive analysis, I've established that there's a lot of or more whites are single compared to blacks. So now I'll say there is a significant maybe difference in marital status among the different races that are there. So you can relate now with what we covered in SPSS class. Step number 3, we said now talk about your confidence level. At what confidence level are you doing your study? Threshold is 95. So if you're doing your study at 95% confidence level, of course now you're saying I'm setting my level of surety at 95. And the error margin is the 5%. So with the confidence level, we will be able now to get the alpha value, which is 0.05 if you're doing it at 95. This p-value, so this alpha value is what now you relate with the probability value that you will get once you run any of the test statistics that you're going to do. Either you're doing chi-square or you're doing, so there's a p-value when you run chi-square. There's a p-value when you write independent sample t-test. There's a p-value also for correlation. And then lastly, I said what now? Not lastly, I think step number 4, you say now decision making. How do you make decision on whether to reject or fail to reject? And the rule of thumb is when the p-value is less than the alpha value, then that is when you reject the null hypothesis and go for the alternative. And it's not that always at all time you will be finding a p-value that is less than alpha. No. So once you have decided on where to go, now we can talk about step number 5, which you said is what? Now conclusion. If you reject the null hypothesis, then that's what you'll conclude. So let me start with the correlation. Let's start with chi-square. And you said for chi-square, this is where you are checking relation between 2 or more categorical variable. So I want to know if there's a difference. Let's look at race and college graduate. And I'll show you 2 ways of running chi-square. One, we start with the point and click, and then we also do the command. So if you go to statistics, summary tables and tests, tables, statistics, summary tables and tests, and then tables. So of course, there's a lot of things that you can do here, but now that we are constrained with this session to some certain areas, so I'll just stick to summary tables with two-way table of summary statistics, one-way, two-way tables. And now the variable is, okay, we have to do it again. So we say statistics, summary tables, and then we're doing one-way or two-way. Okay, so we're doing two-way tables with measures of association. Because now we're doing actually chi-square tables of association. So we are not going for just two-way table of summary statistics. I think let's do now two-way tables with measures of association. And the variable is race. I'm cross-tabulating against, we're doing what? Graduation, college graduate. And the test statistic that I'm doing is chi-square. So we talked about this. So just unless you want to get the results for all these things, I'm doing the bare minimum. And I'll also advise you, don't select results that you cannot explain. So in an event that you're running an analysis, just by sticking by Pearson chi-square, you'll be achieving your goal. But if you want to talk about likelihood ratio chi-square, you can still do that. You can, now let me mention about Cramer's. I think I talked about this in SPSS, but I said what Cramer's Kendall-Stowe A, Kendall-Stowe B. We have now the Goodman and Kruskal gamma. All these are now what you call the non-parametric test. So in an event that you had confirmed that your data is normal, then that is when now, based on the assumption, you know, are we doing Kendall-Stowe A or Kendall-Stowe B? But since we are doing, this is a beginner class, then we will stick by Pearson chi-square. That is on the test statistics, step number 1, not on the cell content. If I click OK, now you can see that first I get that descriptive table, and then my p-value is now this PR, and I have a figure of 0.00. And what does this mean? So in our step number 4, we said in an event that the p-value is less than the alpha value, that is when you reject the null hypothesis. And in this case, my p-value of 0.000 is less than 0.05. So I will reject the null hypothesis. Now let's remind ourselves of what the hypotheses were. And it's good, before you even run that analysis, you must make sure that you have deliberately stated which is the null and also which is the alternative. So in this case, the null hypothesis will be there is no relationship between someone's race and them graduating. The alternative hypothesis will be there is a difference between So I know, just give me 10 more minutes. We have time, but 10 minutes time we should be good to go. And I'll also emphasize that some of these things that I'm talking about, I'll be able to share again those recordings so that you review them at your own pace. So as we wind up, I've just talked on chi-square, and I've used the point and click. So as much as I'm introducing commands in these classes, also I know there are some of you who are comfortable with just pointing and click and getting the results. So it's good when you also interact with both sides. So I say tabulate. What are we tabulating? Tabulate race against college graduate, comma, English in space, comma, and then chi, thi, squared. So that's the test that you're doing. So you have to specify what test statistics are you doing. So I'm specifying using a comma that I want a chi-square results for race and college graduate. If I execute that, I'm getting the same results. Let me stop there, and I think we'll have to proceed tomorrow, and I'll be winding up now with the remaining inferential analysis part again in our session tomorrow. Any question or concern up to this point before we call it a day? Anyone who has a question or concern up to here? Okay, so if there are no questions, then I will be the one having questions for you. And most of my questions will come from the quiz. And I said the quiz, you can be able to get it from the STATA 12 windows. There's a lot that you can revive on econometrics. And I gave you a small task to look into question 1 up to question 4. So I hope you know by now R squared and adjusted R squared a bit of it, and I emphasize on reading the linear regression file. Guys, thank you all for your time, and let's meet tomorrow same time. And what mistake? If you're still there, I don't know if you're still there, just maybe clarify what issue are you facing on your end. So I think let's meet tomorrow. Just hang in there. Maybe tomorrow we can discuss more on your command, the tabulation. So in shida, let's discuss that. The first thing before we do anything tomorrow, I'll start with the error that you're getting.